Okay. Here's the beginning of the test review. Again, if you need to pause something to make adjustments, I'm going to go kind of quickly, but explain through each problem. Alright, so for G1, for number 1, this should be an exponential decay because the base is 1/2. Right 2 up 4, your y value is 6, 3, 3.5. And then when you graph your points and then shift them, your graph should look like it's decaying quickly over time. Make sure that you draw on that asymptote as a dashed line. For number 2, same type of deal, except this one has a negative number and it is a growth, but because of that negative, it's going to flip it over that asymptote, so it's going to look like it's increasing downward. Your y values, remember when you're plugging in a -1, the negative exponent flips it, so that becomes not 4 to the -1, but actually positive 1/4, and 1/4 times -2 is -1/2. Then shift and domain and range. For number 3, a situation that would be modeled by an exponential growth or decay, make sure that you're specific in your example and give clear indicator words so that I know if you're trying to describe a growth or decay function. And it should be realistic. So something that would realistically increase or decrease by a certain percentage. Okay, number 4. And you can probably see number 4, 5, and 6 here. Keep in mind that when you compound monthly, you do have to, I've noticed on some of your papers that you're not multiplying by the end value in the exponent. Make sure you do that. And then for 6, whenever you see the words compounding continuously, you have to use the PERT formula. So just be aware of when those two words are there. And then for 7 and 8, 2 examples in which you're increasing or decreasing in one time frame, and I ask you to rewrite it so it's in another time frame. And when you're decaying, such as this one is, when you rewrite the base, you have to find the rate of decrease. So I usually take that and subtract 1 to get that decimal. And then rewrote it as a percentage. Okay. Number 9. Expanding expressions. Remember to use the 3 letters D, M, P. Do division first, then multiplication, then powers, and then down here, P, M, D, switch the process. And then for the 4 type problems, these are when you have multiple divisions going on. So I took care of the multiplication first, and then I did my first division. And this divided by z would be like a fraction divided by fraction, so you have to flip and multiply. And I do it the same thing here, but that would end up being your final answer. You'll probably have a few more steps, just so you're aware. Okay, and then number 12 and 13. Remember, when your base is not E or 10, you have to use the change of base formula when you're plugging out the values. And then when you draw in your graph, it should increase or decrease slowly over time, and your asymptote should be vertical. Now, probably for 14, the best answer that you could have there would be one that has almost all, if not all, of the qualities that we talked about today in class with the 4-type practice that you kept. We've made a big list of characteristics, differences, and similarities. And then you would just have to write that in sentence form. Okay. And flipping. Our last standard, solving exponential and log equations for 15a. This is an exponential function set equal to an exponential function. So we have to rewrite the base. So I'm rewriting 32 as 2 to the 5th. Can't change what it is. 2 to the 5th is still 32. We just can change the way that it looks because we're going to use a one-to-one property, which basically says if you can get the bases the same, you can set your exponents equal to each other. Now when we make this 2 to the 5th, you're multiplying 5 and the 4x plus 7 together, so you distribute through. That's where I got the 20x plus 35. And after that, it's just solving for x. Here, you're isolating log base 4, so you'd subtract 5 divided by 3 to get 7/3. And then you exponentiate both sides. So since the base is 4, I'm going to raise both sides to be a power with a base of 4. And 4 to the 7/3 gives you 25.398, and then it's just solving for x, so we add 2 divided by 5. For C, 2 to the 3x minus 4 is what you have to get by itself. So we add 8 divided by 5, and then to get rid of the base of 2, since this is exponential, we take the log base 2 of both sides. Now over here on the right, in order to punch that out in a calculator, I have to do change of base. So ln of 18 over 5 divided by ln of 2 is that decimal, and then I add 4 divided by 3 to get that answer. For D, this is set up as a log set equal to a log. The bases are the same, so in order for that equation to be true, the arguments would also have to be equal to each other. So we set the arguments equal and solve. And then here, we're getting the ln by itself, so add 12 divided by -3, you get 8/3. And then to get rid of the ln, we have to exponentiate both sides using a base of e, because the e and the ln cancel, leaving me with this. And then we subtract 3 divided by 5 to get 2.278. And then for 16, we have to condense the left side first. So I'm going to use the product property here, because that plus, you'll notice that the argument now is x plus 2 times x minus 1. And then we exponentiate both sides to get rid of that log base 3. And I FOILed my argument together to get that. 3 squared became 9. Subtract 9, and I have a quadratic, and I'm going to solve that quadratic using the quadratic formula. So this is the most simplified answer that you can have, but I would probably accept that as well. Okay, so that should give you some good feedback on what to look for the test tomorrow. Your test will be very, very similar. After you finish your test, if you need to finish your application test, you can do that. And then you're going to be doing, we have a short day tomorrow, so you might just have to do those two things, the test and then the application test. All right, this is Crisscross signing off.